All right, good morning, guys. Now we are going to do online learning without Zoom. Till we find a replacement, I'm just going to post these videos so that you can still kind of see the lesson live. This is 13.1, part 2. There's an online worksheet. The worksheet shows 3 pages, and I sent you a Schoology update saying you are not doing all 3 pages. The third page has like a combination of triangles that are touching. If you want to practice some of those, you can for the test because it will have one of those on there as an extra credit, but you don't have to do that problem if you don't want to. So the homework is only the odds, and it's only the first 2 pages of that worksheet, meaning the front and the back if we were in class with regular paper. So special triangles are something you have done before in geometry, but it's also kind of a sticky point. People struggle with it. So I always take a 3-step approach when I'm doing these. What you'll be doing is looking for the sides of the triangle, always. We've done that using Pythagorean theorem. If we know 2 sides, we've done that using SOHCAHTOA if we know a side and an angle. But today we're going to be given just one side and then these special triangles where you don't give decimal answers. You have to find it as an exact value, meaning with radicals simplified and reduced. And that can always be tricky when you're managing radicals. So the 2 special triangles are 45, 45, which is a square that's been diagonally sliced in half. So you'll know it's a 45, 45 because they'll have those labeled. Or you'll see that 2 sides are marked as the same length, and that will be the giveaway that it's a 45, 45. Then your job is to know what those relationships are. So in that type of a triangle, these 2 sides will have the same length. And I always label them with N's rather than X's because if the question has X's in it, then I get confused. So I use here and N for the 2 legs, which are the sides that come together at the 90. And then the hypotenuse is that number times the square root of 2. And I always remember that that goes on the hypotenuse because it's got the 2. So once I have that labeled, my second step is going to be to solve for N using the given side, and I'll go through the examples. And then my third step is going to be filling in the other sides using the N value. I can see you guys have a little glare here, and I apologize. The lighting's just bad because it's gloomy out. The second special triangle is a 30, 60, 90. And in this one, the shortest leg, meaning across from the 30, is going to be your N, your plain old N. So once you know it's a 30, 60, 90, label that short side N. And again, the 2 goes on the hypotenuse. So this one is twice as long as that, always. The relationship will be twice as long as that. And then the third leg is going to be that N value times the square root of 3. And so you want to know these. This is going to be something you just have to know so that when you've decided it's a 45, 45 or a 30, 60, you can label it appropriately. So what does that look like in a problem form? Looking at the question on the notes packet, the example, it's got a number 4 there because remember this is actually the second part of 13.1. And the only thing it has labeled is that this is 8 and this is 30 degrees. So if I'm approaching a question like this, I go, okay, well, it's obviously a 30-60 because it says 30. So I'm going to go ahead and label the short side N, the hypotenuse 2N, and the third side N root 3. Done. Now I'm going to solve for N using the given side, which is this. So if 8 equals 2N, dividing by 2, then N is obviously a 4. So now I'm done with step 2. So the last thing I do is go around and fill in the other sides. So if this is an N and N is 4, then this side of my triangle is a 4. And down here, I'm supposed to take my N value, which is 4, and put it in front of a root 3. So now I know that the 3 sides of the triangle are 8, 4, 4 root 3. So that's how I would tackle really all of these. This can be easy, like here, solving for N was easy. I just divided by 2, but some of them get messy because of the radicals. So I guess that's always the case, is the math concept isn't that complicated, but sometimes the radical can be. If I'm looking at example 5 on the notes packet, I see that they have this marked as a 45. They have a 5 over here, an X up here, and a Y down here. And that's exactly why I don't use X's to label my sides, because then these get confusing to me. So because it's a 45, I know it's a 45 triangle, and I'm going to go ahead and label the sides that make the 90, the two legs, as n, and my third side as n root 2. Then I look around for the side that's labeled, which in this case is the n, and that's awesome because I would have to solve for n normally, but they just straight up told me it's 5. So now, third step, I fill it in. This side is also n, which means this side is a 5, so my y must be 5. This side, I'm supposed to take my n, which is 5, and put it in front of root 2, so then my x must be 5 root 2. So your answers on these will not be decimals, and if you use decimals, you won't have the right answer because we're looking for simplified radical expressions for answers. I'm going to do a couple more, but really they're all the same. The worst case is when you have something like number 6. Let's take a look at that one. So here I have a I have a 45-45 based on the markings. They're asking me for this side, and then they're giving me a 12. Okay, so what makes this one tricky? First of all, it's 45-45, so this is going to be n, the 2 that make the 90, and then n root 2. So here's where this one gets a little messy because now when I go to solve for n, I'm solving for the fact that the n root 2 side equals 12. So to get n alone, I need to divide by root 2. So then now I have this, but I can't have that just because it's got a radical on the bottom. So now I have to rationalize that. So now n equals 12 root 2 over regular 2 because these turn into the square root of 4, which is just a regular 2. But one more step, these can reduce to 6 root 2. So I have to do all of this work to do step 2 and solve for my n. But the good news is now to fill in the other sides using the n value, these are both just equal to n. So if n is 6 root 2, so is this side, and so is this side. So in this problem, both the x and the y have that 6 root 2 as their value. So those are the tricky ones where you have a regular number and need to change it into a radical. Excuse me. Okay, there is one more example on there. I'll do that. And then again, you are responsible for doing the first 2 pages of odds. The evens are posted on the answer key, so you can use my work to help you get through them accurately. Okay, sorry about that. So in number 7, this is 30, and this is 7, y, and x. So I'm going to bust out my labels, and I'm going to go ahead and say, okay, this is a 30, 60, 90. My short side across from that will be n. My hypotenuse will be 2n, and my other leg will be n root 3. So this one's going to be messy as well, because when I get to step 2 and I'm trying to find n, I again have n root 3 equal to a regular number. So I start to solve for n by dividing by root 3. Now I have that, but I can't have that with the radical on the bottom, so I end up with 7 root 3 over regular 3, because again, these turn into the square root of 9, which would become a regular 3. In this case, unlike 6, these don't cancel, so that is my n value. So I go back up here and say, hey, this n side is 7 root 3 over 3, and so that's my y value. And then this one is going to be 2 times my n value, so I have to think, what is 2 times 7 root 3 over 3? Keeping in mind that 2 is like a 2 over 1, so these two would become a 14 root 3 over 3 for the 2n side, meaning my x value is that 14 root 3 over 3. There we go. So hopefully those examples and that explanation together maybe with the hand video can help you guys out. Otherwise, shoot me an email if you have any questions, and we're going to set up a Schoology conference soon, which I think works similarly to Zoom. So let's see here. I think we're done. Bye, guys.